I just want to say hi and welcome to everyone. This is our first webinar of the year, and we will talk about what's new in NetXMS today, and specifically about new features in NXSL language, built-in interface traffic template, and finally, fan-out driver for ClickHouse. Don't forget to like and subscribe and support our NetXMS channel. And meanwhile, maybe Philip will start with the templates. Let's do like this.
Yes, let's do this.
Okay.
Yeah. Okay, so hello everyone. A couple of things which we added in NetXMS version 5. We've made 2 templates. So let me start from the one which is related to energy monitoring. So modern CPUs provide energy monitoring metrics, and in version 5, support for this was added into the agent, and we've made a template which you will probably get when you upgrade to version 5. The thing is, let me remind you that we have a setting. So if I search for import in server configuration, there is a setting, server import configuration on startup, which by default is set to only missing elements, which means that if we add a new template, it should get automatically imported. But if you have set it to never, then you won't get the newest templates. And if you know for sure that you won't be editing out-of-the-box templates, then it could be better to change these settings to always, because in this case, also changes which we made in already existing out-of-the-box templates, they will also be imported, so you always have latest and greatest templates. Right. So for Intel RAPL energy consumption template, basically just 4 DCIs. The way how we interpret this data as is that we can calculate current consumption in watts, or we can count joules, which will be actual energy consumed. And in this template, we made both of them. So we have a couple of DCIs in joules and a couple in watts. So you may choose whatever you like. And if you look on how it looks on some working system, right, so basically this is my laptop, which supports these metrics, and we get total consumption. And let me see if I do instance discovery poll. I believe we should get okay. So if specific system provides counters, you would see additional metrics for separately for CPU cores or for memory modules, right? So this goes to energy consumption. And the other set of templates, which we now have here, it's interface traffic templates. There's actually 3 of them, because there are 2 separate templates for agent metrics. One is for systems which provide 32-bit counters, and another for 64-bit counters. For SNMP, it's a bit more tricky because some interfaces may provide 64-bit counters, and some interfaces, if they are running on 10 megabits, for example, they would provide only 32-bit counters. At least that's how it happens on Cisco, and we basically use this approach everywhere. Right, so if we look at comments tab for these templates, we will find some information on what it is and what it is doing. And important thing here is that these templates require specific custom attribute to be set. And so by default, this template won't be applied anywhere. Why this is so? Because you may happen to have, I don't know, 5,000 of switches in your network with tens of interfaces on each, and this will create a lot of DCIs, basically a lot of load to your database. So that's why we didn't make it default thing. So let me do this for my system. I will just set this custom attribute on infrastructure services. So, right, so it should be yes, and I enable inheritable checkbox so that this custom attribute is propagated to all my nodes. Right, but if you have a more complex object hierarchy, you may want to specify this custom attribute on some container and not on the root, so that it's propagated to your nodes only from one object, so that we don't get custom attribute propagation conflicts. Right. So I have my custom attribute, and if I now go and do automatic binding poll for my template, it will be applied to a number of nodes. So I will also do this here. We don't really need to do it manually because in a while this will happen automatically. So I'm just doing this to speed up things. And let me see. So, okay, so this shelf switch should have something. The values are currently just 0 because these are delta counters, and we need to have 2 measurements to calculate traffic. So I can just force poll again, and now we have some values. Right. So once we have these DCIs configured, we have a few nice features. And let me just show one thing. So if I go to details of this DCI, to other options tab, we have 2 things. We have related object set, which is pointing to interface object for which these counters are. And the second thing what we have is interpretation. So in this way, we are telling to the system that this DCI, it has a meaning of outbound interface traffic, and it is in bits per second. But yeah, template sets all these things automatically, right? So once we have these DCIs, if we look in the interfaces tab, we have utilization column, and in here the system automatically calculates. So now we have the DCI with traffic. System knows interface speed for this interface, so it can calculate utilization percentage. It's not a DCI, it's not stored anywhere. It's just displaying here. And also, if we look on a specific interface, we also see this utilization here in interface details. You may notice that I have 8 interfaces on this switch, but data collection was added only on 4 interfaces. So the way the template is made, it creates DCIs only for interfaces which have expected state up. So, for example, this interface has expected state down, so we didn't add a DCI for this interface. Right, but it's just a demo template, so you can modify that and adjust it to your needs. So if we click on an interface, we have utilization, and we have a nice chart. This is actually a feature from development version. So this is not yet released, but will be in the next release. So once we have these DCIs, there is also another nice place to use them, and that is on network maps. So in properties of network map, if we go to map options, there is a checkbox, display traffic data, and what this does, it automatically adds data collection items to corresponding links. Right, so so it was a switch we were looking at, and now we have data collection items on both ends of the link, because on this end we have DCIs which are collected from this switch, and on the other end we have DCIs collected from this core switch. That's basically it about this template. We tried to make it as generic as possible, so it works on all devices, but it still may need some improvement, because, for example, if you have a device which doesn't provide interface counters under standard OIDs, this template won't work. So we will need to add some exclusions into automatic apply rules and create another template for your specific device.
Let's switch to Victor.
Okay. Okay, so now we have 2 more topics, short ones. The first one is some new features in our scripting language in NXSL. So the first one is that in NXSL we have mathematical functions like mean, max, average, standard deviation, mean absolute deviation, and now all of them support or accept variatic arguments. So now you can do something like this. And you see I have an array of values, and I call the mean function and max function, standard deviation function, and I can actually mix and match arrays and values, and it will be combined at a single set, and then the function will be applied on that set. So here I have 2 primitive values and then an array, and I got the result. I can just pass array, of course, and I will get my result from the array, or I can use array expansion, I suppose, and get my result from the array as well. So a lot of different options just for simplicity. We also have added a new function that sometimes is needed, which is a sum of all values. So it follows the same pattern. You can pass arrays, you can pass primitive values, and it will produce just sum of everything. Okay, next small improvement is that we have added indexOf method to the arrays. It looks like this. So if you have an array, then you can call indexOf and pass the value. And if such value are present in the array, then it will output the index of this element inside the array. And if there is no such element, it will return null. So you can check. You can directly use result of indexOf in the logical expression. So you can basically write something like this. Present. And we have present, and if I put something non-present, I will get not present. Again, for simplifying the scripts. Next one is that we have added ranges very similar to what you can have in Python, again, to simplify loops. So instead of writing something like for e equals 0, e less than 10, plus I, and you will get 10 numbers from 0 to 9. You can write it like this. There's a keyword range, and then you just put 0 to 10. So the last one is non-including. So it's from 0 up to 9. And you get the same result. And in the same way as in Python, you can actually put only one argument, and then 0 is implied as a low border, and then so it will be from 0 to 10. So okay, we get the same result. And the last form is that you can give a step. So here we have range from 0 to 10 with step 2. And so we have 0, 2, 4, 6, and 8 as values for our enumeration. So this is simple, but reduce like noise in the script, so you can have them more simple and more understandable. And finally, we have added Unicode escape sequences in NXSL string literals. So if you need to insert any Unicode character, you can use this form. And then \u, and then 4 hexadecimal digits. A5, for example, 0085. If I remember correctly, it should produce the yen symbol, and here it is. So again, if you need to format messages with some special characters, you can use this escape sequence instead of trying to copy-paste those symbols into NXSL source code, which may lead to problems when storing in database and so on. Okay, so that was about our latest NXSL changes. Next topic that we wanted to share is that we have added fanout driver for ClickHouse. So we had a fanout driver for InfluxDB for quite some time, and in version 5.2 we have added a similar driver for ClickHouse. Because ClickHouse is a bit different from Influx, so it's basically a database with a schema. you need more complex mapping before you can send data to ClickHouse. So I will show a simple extract from configuration file of the server. So you configure everything inside netxmsd.conf. Of course, you specify that you have performance data storage driver ClickHouse, and then you have a configuration section for ClickHouse driver, where basically you give the connection options like the host name, port, if we use HTTPS, the database name, name of the table, login and password. That's just connectivity parameters, pretty straightforward. In the same way as with InfluxDB, you can turn on and off unsigned integer types. Again, the same as Influx, you can turn on value validation and value correction before writing to the database. And then we have a new feature that was added to InfluxDB as well. Now you can also use template custom attributes for mapping data or for providing additional data for fanout drivers. So before 5.2, InfluxDB driver will read custom attributes, specially formed custom attributes from node, which owns the DCI, and from related object. Usually it's in an interface. So if there is a related object set for DCI, then its custom attributes will be read as well. Now, it's also possible to turn on attribute reading from the template. So if DCI comes from template and this configuration parameter set to yes, then NetXMS server will also check list of custom attributes on that template. Our clients use it to provide additional information about DCI based on which template it came from. For example, if you have all the interface traffic DCIs in one template and CPU utilization DCIs in another template, you can set custom attribute on the templates with the DCI type attribute, for example. And then this attribute will come to the database and it will allow you for easier filtering based on this attribute value. And then because ClickHouse is a column database, so it's not like free form, you have to do mapping between columns in your ClickHouse database table and the data. So there is some standard data that you can map. There's a timestamp, host name, DCI name, its integer value, its floating point value, instance of the DCI, data type, data source, delta calculation type, and the text. So for you can omit some of them. Of course, you need timestamp, you need host, you need name, you need probably at least one of the values, and then the rest is pretty much optional. If you don't need it, you can just don't map those columns. Column name tags, those are the same tags with the same logic as for InfluxDB. So if we have the node and we want to send something as a tag together with the DCI, we go to the custom attributes and we just add an attribute tag and the value. And if you have this, and the ClickHouse driver will find it, and it will add a tag named my tag with the value 1 to 3 to the outgoing DCI. And you may also want to have some additional columns because the text column, it's a map, and it's not really good if you want to do queries based on those tag values. It will be just too slow. So you may want additional columns, and so you can have one or more parameters called column.additional data, where you specify the column name and the data type for this column. And a server will look for custom attributes with prefix column instead of tag. So you will have something like column, my data 1, value 44. So if I have something like this, that means that for column named my data 1, I will have value 44 on all DCIs that are on this particular node. Or if I have enabled the template attribute scanning, then also I can set it on the template level. And then we have pretty much the same parameters controlling queues for sending out data. It's absolutely same meaning, same parameters as for InfluxDB. So you define the minimum size of the queue to flush. So if the outbound queue reach 1,000 elements, in my case, it will be, those elements will be actually sent to the database. You can also put upper limit on the queue size. If driver cannot keep up to speed with sending data and the queue grows, if it grows up to the limit, the new data will be just dropped, so you will lose some data on the ClickHouse interface. And also you can set maximum cache wait time in milliseconds. So if queue did not reach a flush threshold within the max wait time, it will be flushed anyway to avoid data being stuck in a local cache for a long time. So pretty much that's it. That's the way for sending out data to ClickHouse for analytics, for reporting, etc.